All right, welcome to The Explainer. We're here to break down the big ideas from the leading minds in tech, and today we've got a really cool one. We're going to dive into a framework from AI expert Andrej Karpathy that might just completely change how you think about artificial intelligence.
So here's the big question Andrej Karpathy is asking, and it's a wild one. Are we building AI that learns like an animal? Or are we basically summoning digital ghosts from the internet? Yeah, you heard that right. Ghosts. Let's really dig into what he means by that.
So, Karpathy's main argument is that there are these two totally different philosophies for building AI. And right now, we've pretty much bet the farm on just one of them.
Okay, so on one side, you've got what you could call the animal vision. Think about it. A zebra foal can get up and run like minutes after it's born. It doesn't sit there with a textbook. That ability is hardwired. It's baked in by millions of years of evolution. So that idea for AI is that it should learn from scratch by interacting directly with the raw world, just like an animal would. But here's Karpathy's big point. That's not what we're doing. Not even close. He says we're summoning ghosts or spirits. And what are these ghosts? Well, they're these strange digital entities born from data. We're training them by having them imitate the entire digital footprint of humanity. Every blog post, every cat picture, every line of code ever uploaded to the internet.
So the obvious question is, how do you actually create one of these digital ghosts? Well, it all kicks off with a process that Karpathy pretty hilariously calls our crappy evolution.
And that crappy evolution is what we in the field call pre-training. It's really the foundational step. You take a massive neural network and just feed it a huge slice of the internet. The whole goal is to give it this incredibly broad foundation of knowledge, a starting point for everything else. It's our fast, messy tech version of what evolution does over eons.
But here's where it gets really clever. Pre-training isn't just about the AI memorizing a bunch of facts from Wikipedia. The real magic happens because you're forcing the model to do one simple thing over and over: predict the next word. When you do that across trillions of examples, it has to do more than just memorize. It's forced to actually learn the underlying patterns, the algorithms of grammar, logic, and even reasoning. This is how it develops what Karpathy calls a cognitive core.
Okay, this all sounds great, but let's do a neural signal check. Because this whole summoning a ghost approach, as powerful as it is, creates some really deep, really tricky technical problems. These are the kinds of headaches that researchers are losing sleep over right now.
One of the biggest problems lies in how we try to fine-tune these models. A popular method is reinforcement learning, or RL. And Karpathy, well, he doesn't mince words. He calls it terrible. His analogy is perfect. Using RL is like trying to get all the information you need by sucking supervision through a straw. It's incredibly inefficient.
So what's so bad about it? Let's break it down. Imagine an AI trying to solve a complex math problem. It tries 100 different paths, makes a bunch of mistakes, and finally stumbles upon the right answer. What does RL do? It gives a single correct signal at the very end. The AI then looks back at that entire chain of thought and basically assumes every single step it took, even the dumb mistakes, was brilliant. It has no way of knowing which part was the key insight. That's a super noisy way to learn.
And if that wasn't enough, there's another major flaw we have to talk about: model collapse. This is a seriously weird phenomenon. It's what happens when an AI starts to be trained on its own output. It can get stuck in this feedback loop, becoming less and less diverse until its responses are just a pale imitation of the original rich data it was trained on.
Have you ever noticed how a chatbot seems to tell the same 3 or 4 jokes over and over? Well, that is model collapse in action. The model hasn't forgotten the thousands of other jokes it learned during pre-training. But it's become, as Karpy puts it, silently collapsed. It's like it's stuck in a rut, only able to access a tiny, well-worn path of common responses. And this slide really gets to the heart of a fundamental difference between us and them. For a large language model, being able to memorize insane amounts of data is a feature. But for humans, being kind of bad at rote memorization is actually a feature for us. It's a bug that's a feature. Why? Because it forces our brains to stop memorizing and start generalizing, to find the underlying patterns and concepts. So a huge goal in AI research is to figure out how to get the model to do less memorizing and more generalizing, to really isolate that cognitive core. Okay, so we've talked about these fundamental flaws. The big question is, what does this actually mean for the future? Well, it turns out these problems are precisely why building useful AI assistants, what we call agents, is so incredibly difficult. You hear a lot of hype right now about this being the year of agents, but Karpathy really pushes back on that idea. He says you should think of an agent like an employee or an intern. And the reason we don't just hand off all our work to them today is because, frankly, they don't work. They're cognitively lacking. He thinks we're not looking at a year-long project here, but more like a decade-long challenge. You know, looking back at the history of AI, it's not a straight line. It's full of these seismic shifts. Karpathy points out that back in the mid-2010s, there was a huge focus on reinforcement learning in games. But he sees that as a kind of misstep. Why? Because the truly crucial unlock, the powerful base models from LLMs, hadn't been invented yet. It was like trying to build the roof of a house before you'd even poured the foundation.
All right, so if this whole ghost in the machine has so many issues, what's the path forward? How do we eventually get to agents that actually, work?
Well, according to Karpathy, there's no single magic bullet here. There's not one breakthrough that's going to solve everything. Instead, progress is going to come from slow, steady, simultaneous improvement on all fronts. We're talking better algorithms that aren't as flawed as today's RL, much higher quality data, faster chips to run it all on, and totally new model designs that can sidestep problems like model collapse.
He has this great phrase for it, the March of Nines. Think about it. Getting a demo to work 90% of the time is hard, but it's doable. But getting from that 90% reliable demo to a 99% reliable product, that can take just as much work as the first 90%. And getting from 99% to 99.9%, that's another monumental effort. Each extra 9 of reliability is its own mountain to climb, and that's why this is a decade-long problem, not a year-long one.
So this all leaves us with one last, pretty provocative thought to chew on. If Karpathy is right, and we're not training animals but summoning ghosts from the collective digital echoes of all human knowledge, what kind of spirits are we actually creating? And maybe more importantly, when we look into them, what part of ourselves will they ultimately reflect back at us?